Okay, hello. So this is the second honors topic for chapter 5 for Algebra 2. So what we're going to be doing here is identifying even, odd, or neither for a function. So if a function, like every function, has some kind of symmetry about it or no symmetry at all. If we're talking about even or odd, that's saying that there is some symmetry about it. If it is neither, that means that there's not any symmetry about it. So let's put 3 graphs up on the board. We're going to talk about what this looks like algebraically, but also graphically. Okay, so if a function is even, that means it has symmetry about the y-axis. So I have something like this that goes and has the exact same thing on the other side. So if I took this graph right here down the middle and I folded it in half, it would have to match up perfectly because it's symmetrical along the y-axis. So when a function is odd, it is symmetrical about the origin, meaning some kind of function like this. What I like to say is if I, and this is not a perfect drawing by any means, but if I put my finger right here in the middle and I spun this thing around and I landed back right here, this side matched perfectly up with this half matched perfectly up with that half. So symmetrical about the origin is odd, symmetrical about the y-axis is even. If something has no symmetry, like this one, this function, it's neither, right? There's no symmetry about the origin or the y-axis. If I folded it in half, it would not match up. If I spun it around, it also would not match up. That's what it looks like, or graphically, sorry, not algebraically. Algebraically is what I'm a little bit more concerned with. I think just looking at those two things, you'd be able to tell graphically. Algebraically, though, we do this test. So we do a composition of functions, and we say if we insert a negative for every x we see, and it comes out positive, then the function is even. If we insert that negative and it comes back out as, sorry, how do we do this? And it comes back out negative, right? Do I want to put it notationally? Yeah, sorry, I wanted this in front. I second guessed myself, but I didn't want it in front. And it comes back out negative, then it's odd. Okay, so what if it never comes back out? What if our f of negative x never ends up equaling f of x, positive or negative? That is going to be neither. Okay, so we're going to take a set of steps here. I'm going to erase this real quick, sorry. If you need that again, go ahead and pause and write that down. We have a set of steps that we do in order to test this. So I'm going to ask you to prove if f of x equals x cubed minus 7x. F of x equals x cubed minus 7x. I want you to prove odd, even, or neither. Okay, is this function odd, even, or neither? So the way that we do this is we always start by trying to put in a negative for that x. So I say f of negative x. So you know when we substitute something in for x, we put that in for every x we see in the original equation. So here I have to put in a negative for x and a negative for x down here. So we want to try to actually solve this out. So anything that's negative to an odd exponent remains negative. So this will still be a negative x cubed. Negative 7 times negative x is a positive 7x. So I want to see at the end of this whole thing, did I end up with my original equation? If yes, then it was even. If no, then we have to test for odd. So I have negative x cubed versus a positive x cubed. So already I'm saying, no, it's not the same. But also a positive 7 versus a negative 7. So what I have is not exactly what I started with. That tells me not even. Okay. From there, we want to factor out a -1. So I'm going to factor out this -1 and say I change both of these signs because negative divided by negative becomes a positive. Positive divided by negative becomes a negative. Now, if what's left inside of my parentheses is what I started with, then it's odd. Okay, so positive x, -7, -7. That matches perfectly with what I have in parentheses. Disregard the negative out here. You get to say yes, it's odd. Okay, let's try another one. And that's it, like that's all you have to do. You just have to say odd, even, or neither. Sorry, just for a second, I want to find a different one. Let's do x to the 4th plus 2x squared. Okay, so again, we always start off by testing for even. So we insert a -x. Every place we see x. So we have -x to the 4th plus 2 times, I don't know why I put -4, sorry, -x squared. So anything that's negative to an even exponent is going to become positive. So now I have positive x to the 4th. Okay, again, order of operations says I do exponents before I do my distribution or multiplication. So -x to a positive x or an even exponent is going to be positive, what am I doing? Positive x squared, giving me x to the 4th plus 2x squared. As soon as I fully get this simplified down, I say, is what I have now exactly with what I started with? If yes, then this function was even. Positive x, positive 2x squared, positive 2x squared. So I get to stop here and say yes, even, and then I don't have to do any more tests, okay? So let's say I tested for even, it's not even. I tested for odd and it's still not odd. Then you would say this function is neither. It's not odd or it's not even. So it has no symmetry. Okay, let me know if you have any questions with this. I can show you lots and lots of examples if you need some more of these, but these are the two basic kinds of things that you're going to see when you're solving these.